Hello guys, welcome to learning microcontrollers. In this video, I'm going to show you how we can interface a PIC16F877A microcontroller with an LM35 sensor, and we'll use a Nextion touchscreen to display the output. So we will be using a temperature sensor to send data to the PIC16F877A microcontroller, and then we will display the temperature on a Nextion touchscreen. So this will be a very useful project, especially whenever you want the sensors to display value on the touch screens or HMIs. So the programming tool I'm going to use here is the MikroC for PIC. So let's get started. So guys, this is our Nextion screen I'm going to use. It's a 2.8-inch Nextion screen. This is its bottom side. On the bottom side on the right, you can see this is a model number. You write it down because it is important. Whenever you will use the Nextion editor tool, you will need this number to select the device. On the left side, you can see this port. It has like 4 pins. Let me label them. Top one is a 5 volt. Second last from the bottom is a RX pin. The second one from the top is a TX. And the last one from the top is a ground pin. They are also labeled on the board as well. These 4 pins represent that it's a UART LCD. So this is a UART LCD Nextion display. So guys, since we cannot connect this directly with a PIC microcontroller because we don't have any interface on it, first of all, we will need to burn an interface into this screen before connecting it with a PIC microcontroller and the temperature sensor. So for that purpose, we will use the Nextion editor software, which is a free tool. And to connect this with a computer, we will need a USB to TTL device. You can use any available USB to TTL device at your place. You can use FT232 or CH340 or any other model like CP102, etc. I'm going to use this CH340 because it was easily available at my place. You can see that on the bottom side, it is labeled. It has like 6 pins. From the front, I am going to label this again for your ease. The top one is a 5 volt. The next from the top is a VCC. The third from the top is a 3.3 volt. The fourth from the top is a TX. The fifth from the top is RX. And sixth from the top is a ground pin. You will remove this jumper. You do not need the jumper. Now let me show you how to connect this CH340 device with the Nextion touchscreen. Whichever USB to TTL device you will use, you will always have these 4 wires: TX, RX, ground and 5 volt. Rest may be 1 or 2 less. Some devices might not have 3.3 or VCC, but these 4 wires are must in all of these devices. So let me show you how to connect it. 5 volt pin will go directly to the 5 volt pin of the Nextion touchscreen. Then the TX pin of the CH340 will go to the RX pin of the Nextion touchscreen. Then the RX pin of the Nextion touchscreen will go to the TX pin of your CH340, or TX pin of your CH340 will go to the RX pin of your Nextion touchscreen like this. And then ground will go to the common ground. So in short, TX to RX, RX to TX, ground to ground, 5 volt to 5 volt. In this way, you connect a USB to TTL device like CH340 with a Nextion screen. Now you will plug this device into the computer and you will turn on the Nextion editor software, and there you will make this interface. I will make the screen background grow yellow. On the top, I will mention a temperature calculator. Then in the left, it will be temperature in Celsius C. And on the right, it will display the temperature taken from the sensor. On the left again, temperature in Fahrenheit. And on the right, it will display the temperature in Fahrenheit. First of all, we will simply make the display on the Nextion editor. Then we will program the PIC in such a way that it will take the value from the sensor. And then it will send the values to the screen, and the screen will display the value like here. While these variables will remain fixed, while these two will change. These two numeric values will change as per the reading from the PIC. So guys, first of all, we go to the Nextion editor and we make our interface. So for that purpose, let me first introduce you to the hardware as well. So guys, this is the hardware. This is the Nextion touch screen I'm going to use. This is its bottom side. As you can see in the presentation, there is a model on the right and left side. There is a port, and this is a CH340 USB to TTL device I'm using. You can use any other USB to TTL device available at your place. Connections are as shown in the presentation. You can see that. Now let me connect it to the computer. Here it is connected to the computer. You can see that by default I had not burned any sort of display on it. So now we go to the Nextion editor software. Nextion editor is a free tool. You can easily download it from the internet. Simply go to your Google and write down this Nextion editor download. This will lead you to this page. On this you simply click on download, and there he will show you the various versions for different type of systems. So you download for the Windows if you are using Windows, there exe or zip file, that's all. It's a free tool. Once you have downloaded it, then install it and then run it. Let me run it again. Okay, let me turn it on. Okay, let it run the Nextion editor. This is our hardware. Once you install it, you will get on the desktop icon like this, Nextion editor. You double click on it, the tool will run. So here we go. So let me use the window magnifier to zoom it in. Now on the left side, on the top, you have this file button like this. File, click on file, new, and then once you click the new, it will ask you to write the name of the project. I write LM35 Nextion, LM35 Nextion interface learning microcontroller. That is the name I wrote. Now once you have written the name, it will lead you to this window. Now that is model was mentioned at the bottom of your display. So select the model. This was the model mentioned, this one I am using. So I click on OK, press OK. Now whatever the dimension you want, I want horizontal 90 degree. That will do fine. Click on OK like this. Now this is the work area. Here first of all I make it go yellow. To make it go yellow, go to the right. Here you have first you have to click on it. Click it and go to the right. There you have this, select the color you want. I wanted yellow, so it's yellow now. Now again go to the left. In the left you have this text box. You place it here. So you expand it for the first text box. This will be the first as shown in the presentation. Here I will display the timer calculator. So let me first make a font for this. Go to the tools, font generator. You generate the font whatever dimension you want, 16. I make it go 32 like this, and bold. Okay, this will do fine. I click on, I write the name 1AA. Click on generate, select the place, click save. Okay, the font is generated. Click OK. Yes, add it to the font. Now see that on the left side the font is here and ID is 0. Now go to the right, click on this text box. Go to the right, in the bottom you have this text max length. Make it 50 because timer calculator, temperature calculator will have more digits. Now here in the text, write down the text you want to display. By default, temperature calculator. I press enter. Now go there, see, it's now there. Now the background in the presentation was gray, so I make it go gray, this box. For that purpose, go up here. Here you have this BCO. You make it whatever color you want. I make it gray like this. So now we simply press Ctrl C, copy it, and Ctrl V, paste it. Now this is our second box. You reduce the length like this, and this is our third box on which we will display. Simply copy paste the boxes you had created, text boxes like this. So this is our third box. Now change the text on it. By default I want to display here is that temp in C. So max length is 50. Go to the text, write down the new text, temp in C. Press enter. See, it says temp in C. Make it little bit longer. And here by default I want to display nil only. So for that purpose, go to text and write down 2 dashes like this, nil, that nothing. Again copy these two, bring them to the bottom like this. wherever you prefer suitable, look suitable to you. I move both down like this. Now here I change the text, go to the right and change the text like make it F, temperature in Fahrenheit, like this. See, now we are first of all making only the interface here. These three will remain fixed while these values will be updated by the PIC later on. Now in the presentation we had a bit of difference. See, the box is black and the text is white. So we go back to the right, select all four boxes because box will go black here. This is a box color BCO, you make it black, and this is a text color PCO, make it white like this. See, now the box is black and text is white. This is the interface. We now burn it into our screen. For that purpose, go to this upload, click on upload. It will lead you to this window. Just if your device is connected as per connections I had shown, and then it is connected to the computer, then just click on go. It will auto search the port. See, it has auto searched the port. Now it is burning it into the device. See that it is burning the new interface. See, let it burn. It is as simple as that. See, it's done. Now this is our interface as shown in the Nextion editor software. Now we will need to rewire it up with the PIC to do the further programming etc. of this control, because right now we cannot get these values from any sensor or device because we have not designed it to do the same. We cannot get the values until we do not connect the LM35. It will remain like this. So for that purpose we will need to reprogram it. Now let me show you how you do it. Now this is our PIC16F877A microcontroller having 40 pins. It's a DIP version, and this is the Nextion screen from the back. Let me show you how to wire it up with a PIC. It has, like you can see, 4 wires: 5 volt, TX, RX and ground. Now with a PIC you will connect 5 volt wire directly with the VCC pin like this, and you will connect the RX TX pin with the pin number 26 of your PIC16F877A microcontroller, that is pin number C7. And for the RX pin of the Nextion screen will go to the pin number 25 of your PIC16F877A, that is the TX pin of the PIC, that is pin number C6, and ground will go to the common ground of your PIC16F877A microcontroller. So guys, in this way your Nextion screen is connected with the PIC, as simple as that. Now guys, let's connect the LM35 as well. This is our LM35 DZ having 3 pins. You can see that it has 3 pins. Let me label them. The left, from where the writing starts, is basically your 5 volt pin. The center one is the ADC pin. From this you take your ADC value out, and the right one is a ground pin like this. You connect the 5 volt pin directly with the VCC pin of your PIC16F877A microcontroller. Ground pin will go directly with the ground pin like this, and the ADC pin will go to the any available ADC pin of your PIC16F877A microcontroller. I am going to use a pin number A0 for this, like this. In this way our connections are completed. Now let me introduce you to the hardware before we get to our MikroC for PIC programming. So guys, this is the hardware we have here. This is our PIC16F877A microcontroller. This is the Nextion touch screen, and this is the LM35 sensor as shown in the presentation. It is connected with the same connections. So let's get to the MikroC for PIC programming. Our wiring and connections are completed. Guys, this is our MikroC for PIC programming tools. I'm going to use the version 7.2.0. You can use the latest versions as well. Click on File, New Project. This will lead you to this window. Click on Next. Write the name of the project. I write Nextion LM35 Tutorial. PIC16F877A is the one microcontroller I'm using. 20 MHz is the crystal I have. I click on Next and Finish. Now guys, to make our life easier, in one of my previous video I had already shown you, this was the video PIC16F877A interface Nextion touch screen HMI tutorial. In the description of this video, you can see that there is a code like this. You copy it from here from void main to this. I will also add the link of this video in the description, and you can also watch that video that is in very detail like this. You paste it here. Now in this video you can easily see that this is a syntax which is must for sending data to the Nextion screen like this, but here we will simply modify it. Now on the UART one INIT, it means we are initializing our UART port and we are giving some initialization delay, but in this we will add the ADC pin as well, because we have the LM35 sensor which will need the ADC port. For that purpose, write down ADC INIT like this, give some initialization delay. This will initialize all the ADC pins. 100 will do fine like this. Also make the modification, because this code was written on the previous versions. On that these small and capital letters didn't matter, but in the newer versions this matters. So you have to make sure that these are capital starting characters. This must be capital, this must be capital, else it will give error when we will compile. This must be capital. So we do not need this, we will delete this like this, and D of the delay must be capital. So if there is any still problem, it will give us an error. So guys, we have our UART port for the Nextion and we have our ADC pins, and this is the syntax for sending data to the Nextion screen. I will share the link of the video in the description, in which I had already taught you what this means. So I make this delay go less, like 100 milliseconds, to increase the speed of data being sent like this. Now guys, go to the right in the library manager. You have to select the libraries you're gonna use. Expand this. We are going to use the ADC library and UART library. You have to select both. In the newer versions, you have to select these. And we will also need the conversion libraries, because we cannot display floats and integers directly on the screen. We will need to convert them into strings to be displayed on the screen. So the sensor's values first will be converted into a string, then it will be sent to the screen. Now we do the programming. We need to receive the value of the sensor from the ADC pin. For that purpose, we will need a variable in which we will store the value. So above the void main, write down float. Whatever is the variable, I write temp like this. This will take the value. So you write down temp is equal to ADC underscore read data from channel 0. Give some initialization delay. 50 will do fine, or even 20, 10, 30 will do fine, that's optional. So what is happening here is that ADC read command will read data from the channel 0. If you are using pin number A1, then you simply write 1 here. For 2, write 2, rest will remain the same. I am using the pin number A0, so I had written 0 here like this. Now the next step is we need to convert the received data into, you can say, Celsius, because this data is not in Celsius. So for that purpose we use a formula. For using the formula, we will need another variable. Write down float temp capital C, means temperature in Celsius. That is a raw value. Now we convert it to Celsius. For converting it into the Celsius, you write temp C is equal to whatever the value is received, temp multiply by applied voltage, that is 5 volt. In my case, if you are using 3.3 volt, just you have to write that voltage over here, and divided by 10. Now this is a standard formula for an original LM35 sensor. If this formula do not work, it means your LM35 is not original. You need to change the sensor, because there are many Chinese copies in the market. So you write down here, give some initialization delay, 10 will do fine, 10 millisecond like this. Now temp C is our value converted into temperature in Celsius. Now we need to convert this to a char or a string. For that purpose, I write temp C and take another variable temp C1. Now maximum is 6 digit like this. Now this is a 6 digit string for us. Now we need float to string command. For that purpose, go to the right to the libraries, expand this conversion. In that you have this float to string fixed length. This float to string is available in all the versions of MikroC, but this is a new command in latest versions above 7.2 and above. So you double click on it, and here in the example you copy this command like this. You copy this, just press Ctrl C and paste it below the conversion. Now here you replace this with the one from which is to be converted to a string like this, and you replace this with the one in which you have to store the converted value like this. And this is the maximum length of the string. I make it go 4, else it will give rubbish value. Now give some initialization delay, 10 will do fine. Now whatever the value is here will be converted to this temp C. Now we need to display it on the screen. Now here it is 0. Now go to the Nextion editor. Now this is very important. Go to the Nextion editor. Here. Now here it was burned successfully. See that on all the text box there is a symbol called T0, T1, T2, T3, T4. Now this is the one we will address. We need to send the temperature in Celsius to the T2. So you go back to your MikroC programming. We are going to send it to the T2. So you modify it to T2. Write down T2 here. T2.txt, and this is a standard syntax. And now we are not sending the learning. We will send what? Whatever the value is given by sensor. This is the char. That's why we converted it, because we cannot send you can say these values. This is our float values. We cannot send the float value directly on the screen. We need to convert it to a string. So we use float to string command. Then this is our string, and this will be sent to the screen. So first of all, let's build this code and check it. Does it work or not? So it's built without errors. Build it again for confirmation. So it's built without error. Now we burn it and see what happens before we continue to the Fahrenheit as well. Now go to your PIC3 programming software, PIC16F877A already selected. Now go to the file, select the file you just wrote. This is Nextion LM35 tutorial.hex file. Click on write. Okay, the new code is being written. Let me show you the hardware. Sorry, my webcam got disconnected. You can see that 26.9 is the value being shown on the screen by this LM35 sensor. As you can see that. Now what I do is that this is the LM35. I place my finger on it to increase the value. Now see, I had pressed it. See, the value is increasing. So it means that it is showing the correct value, and it's the same temperature in the room at this time. You can see that on the window as well here, that the near temperature at this time in my area is like 27 degrees centigrade. See that 27 in Islamabad. So I place finger, it increases the temperature further. It means this is working fine, the code is fine. Now we also add the Fahrenheit as well. So we go back to our PIC microcontroller programming, and we simply add the Fahrenheit. So for adding the Fahrenheit, let me zoom in. We simply first of all need more variables for conversion. We add float F capital H Fahrenheit. Now we will not be able to display the float directly. We will need a string FH1 5, the same procedure. So we first of all use this variable to convert this to a Fahrenheit. FH is equal to whatever is the value of the temperature in Celsius, that is the standard equation, multiply by 9 divided by 5. 9 by 5 is equal to 1.8 plus 32. This is the standard equation. You can get it from the Google as well. Celsius to Fahrenheit. We simply write the equation, gives some initialization delay, 10 like this. I make it 10 like this, and then we cannot display fh directly. We need to convert it to a string. We again copy this command and we place it here. Now this time fh is to be converted to this fh1. Whatever is in this will be converted to this to be displayed on the screen. Now to display it on the screen, we are again gonna use the same syntax, because this is a standard syntax. You can make a function out of it if you want. We paste it here, but this time we go to the Nextion editor and select whatever is the text box we are going to address. So we go to the Nextion editor and we find out the box. So it is T4. You can see that this is T4. So go back to your MikroC and you address the T4 box. You make it T4. This time send data to the T4 box, not the TempC1 FH1. Now this will send data to this FH1 and will follow the standard syntax. In this way, Fahrenheit box will also be updated. Now we build this code. Click on this build button, check for errors, no errors. Build it again, confirm it. Okay, no error. Save the code, build it. It is better to build multiple times. Now let's get to our MikroC for programming software. This is the programming software. Source file already selected. Just click on write. Let's get to the hardware. Okay, you can see that the new code is being burned. That's why it is not showing any value, because the new code is burning. Okay, the new code is burned. Let's see. Now we also have this in Fahrenheit as well. You can see that this is the LM35 sensor. I am holding it. Now I press it. So I make it warm, so the values may change. So here I press it with my hand. See, the heat from the hand is transferred to the LM35, causing the increase in the values. You can see that both values are increasing as per their requirements. See. So guys, in this way you can use this Nextion screen to interface a sensor with the screen, and these HMIs are very useful in industrial applications and other stuff. Other than this, with the PIC microcontroller you have tons of other pins available. You can connect multiple or many sensors to make better type of systems. So in this way you can even make robots and other electronics as well. And this is a touch screen. Remember that you can also add the buttons here to do various tasks as well. So guys, I hope you learned something from this video. Thank you very much for your time and have a nice day.